Hi all, Jim Pollen here to talk about the verification of the earth fault loop impedance of circuits, ZS. Specifically, safety, methods of testing and features available on testers. So to start with, we're going to look at the Electricity at Work Regulations 1989. As always, safety is the first consideration whatever it is that we are doing. In this instance, Regulation 14 of the Electricity at Work Regulations 1989 has a bearing on what method we use when verifying the earth fault loop impedance of a circuit. The regulation initially states that no person shall work near any live conductor, which of course measuring the ZS of a circuit entails. However, the regulation goes on to give two exceptions. 1. If it's unreasonable for the conductor to be made dead, and obviously it is unreasonable if we have to test it. 2. It is reasonable for the person to work on the conductor while it is live, and again if we have to test the circuit then it is a necessity. Having established that working on a live conductor is required, the regulation goes on to tell us we must take suitable precautions against injury. More later on that subject. So we can now look at the two methods of testing that are open to us. Method 1. We can measure the total ZS with our tester with the proviso of where it is safe to do so. When testing a socket outlet with test leads adapted for that purpose, then working on or near live conductors is not an issue. Other potential problems arise, but more on that later. Testing other types of circuit entail working on live conductors, lighting, etc. So we need to assess whether it is necessary, which arguably, when we look at method 2, it clearly isn't. Another drawback of measuring the total ZS is the possibility of parallel earth paths, and in the example shown, an acceptable reading could be obtained where no earthing is present. Method 2, which is the preferred method. If we look at method 2, we have reduced the risk of live working to just obtaining the ZE at the origin of supply. The remainder of the circuit earth loop impedances are obtained by calculation, adding the R1 plus R2 values obtained by continuity testing. The test results using a 2-wire high current, which gives the highest level of accuracy, are then added to R1 plus R2. Tripping of sensitive RCDs is no longer an issue. Another issue that can arise is RCD uplift, which can increase results by half an ohm. Again, using test method 2 solves that problem as well. A feature found on some instruments is a 3-wire non-trip test, but we need to be aware that because of lower generated load currents, test results are susceptible to variation. A 2-wire non-trip test doesn't require a neutral test lead, and it can be useful in some circumstances. However, it should be used as a last resort, as it's the least accurate of the 3 test configurations. If these are featured on your tester, you can check the results yourself by using all 3 systems on a circuit with no RCD fitted and compare results. In all cases, read the specification given by the manufacturer. So, in summing up, test method 2 is safer, it's the most accurate, and tripping sensitive equipment isn't an issue. Testing an existing installation, an electrical installation condition report, raises issues that will be dealt with in depth in another video. Feedback of any sort is welcome. Email, comments section, or the like button always welcome. And subscribe to get the latest videos. Thank you.